Alright, I'm back, and now we want to talk about the laws of thermodynamics. So in our previous segment, we learned what does conservation of energy mean. That means the energy you start with has to equal the energy that you end with. So another way of saying this is the first law of thermodynamics. So the first law of thermodynamics is going to say that you can't create or destroy energy. So the energy that you begin with has to equal the energy that you end with. And so let's take a look at this first picture here. So there are thermal nuclear reactions occurring in the sun. So it's going to be called nuclear fusion. And so hydrogen is going to be being turned into helium inside the sun. We'll learn about that later. Okay, but just take my word for it. The energy that comes out of the sun is coming from nuclear explosions. Okay, now that energy then can be used to grow corn. So a plant, through photosynthesis, can grab energy that is coming from the sun, and it can use that energy then to make its tissues. So it can make its leaves, and it can make the corn using that energy. Okay, then the next picture shows a person eating the corn. So the energy that used to be in the sun is now in the corn, and then the energy that was in the corn is now in you when you digest the corn. And then the last picture there shows you can get on your bicycle, and so the energy that came from the corn then can be used to bicycle. It can turn the bicycle wheels. So these are all different kinds of energy. So we're starting with nuclear energy. We're going to chemical energy. The chemical energy then is being turned into ATP, energy that's going to be stored in your muscles, and then you release that energy when you're bicycling. So notice that the energy, the total energy that's coming out of the sun is then being used in each of these different processes. However, you're not using all of the energy each time. So the sun produces a tremendous amount of energy, but not all of that energy is turned into corn. So a lot of that energy is going to be wasted. It's going to be turned into heat. And that is going to be called the second law of thermodynamics. So anytime that energy goes from one system to another system, some of that energy must be wasted. Some of that energy must be turned into heat. So it turns out that, let's say, the energy that is coming from the sun that goes into that corn, well, maybe that corn is only 5% efficient. So only 5% of the sunlight that's hitting the leaves is actually being turned into corn. And then when you eat the corn, well, maybe only 5% of the energy that's in the corn is actually digested and then goes into your muscles. And then when you go to bicycle, well, maybe only 5% of the energy coming from your muscles is actually turning the wheels. And then the other energy is going into the air as heat. So every time you go from one system to another, some of the energy must always be lost. So that there is no such thing as really conservation of energy. You can never take all of this energy over here and turn it into total energy on this side without some of it being turned into heat. So the second law says that in any process, some energy must be wasted in the form of heat. So what's that a picture of? Okay, that's a picture of a refrigerator. Have you ever wondered, when it's on a hot summer day, why not just open the refrigerator? Because after all, isn't a refrigerator a mini air conditioner? So all you got to do is open the refrigerator door and enjoy the coolness of that refrigerator. Well, you could do it, but not for very long, because you would find that if you open that refrigerator, eventually the refrigerator is going to burn out. Okay, why? So take your hand, put it behind your refrigerator, and you'll notice that the back of the refrigerator is giving off heat. Where do you suppose that heat is coming from? Well, two places. So one, it's inside the refrigerator. So the purpose of a refrigerator is to pull heat out of the food, and then it dumps that heat out the back end of the refrigerator. And then remember that there's also motors inside the refrigerator. And then the motors that are causing all the gases and things to move around inside the refrigerator, that takes energy to do that. So you have the heat that's being pushed out the back, plus you have the heat that's being created by the motor in the refrigerator. Now, what would happen if you open the door and you leave it? Well, that heat would travel around from the back of the refrigerator, and then it would go back into the refrigerator. So the heat would go back out the back end like it did before, but there would be additional heat because of the engine. And then that means there's more heat coming out the back end. Now, well, that heat would go back around and go back in, but even more heat would come out the back end. And so eventually the motor would burn out if you did that. Same thing for the radiator on your car. Have you ever wondered, why can't you somehow take the heat that comes off the radiator and then move it around and use that heat to run the engine? You can't do it. Because again, if you did that, so just try taking the radiator off your car and see what happens. Your engine is going to overheat. The engine must lose that heat some of that heat that it's producing and send it off into the air. Now, most of that heat can be used to turn the wheels, but some of that heat must always be wasted. And so that's why a lot of cities are very hot, is because of all the heat being given off by the air conditioners and all the heat that's being given off by the cars. So that's what we mean by the second law of thermodynamics. Now, it's both of these are mathematical, but we're not going to worry about it. So if you can just define what the first law of thermodynamics is and the second law, you're okay. All right, let's take a break. When we come back, we will talk about power.